Hello everyone, my name is Elizabeth and today I'll be talking about challenges with software composition analysis. Right. To start off, a big challenge in software supply chain security is the use of open source libraries or components. Studies estimate around 90% of all software is open source, and the challenge with that comes with that is managing all the vulnerabilities that could be in your components. For example, you may have heard of the famous log4shell vulnerability. So when you have a lot of components in your application, it becomes a challenge when you're trying to manage all the vulnerabilities in them, and various tools and frameworks have been proposed. For example, you might have heard of SBOMs, Software Bill of Materials. Today I want to talk about something similar, slightly different from SBOMs, software composition analysis or SCA tools. They can generate SBOMs for you, which gives you a whole list of all the components in your application, but they focus more on the vulnerabilities in all these components. And ideally, you want them to be easy to deploy, to identify your components correctly, and only alert you on vulnerabilities that matter and how to fix them. But there have been a lot of discussion and various complaints about SCA tools. For example, the large number of alerts, overwhelming developers and users, also unclear suggestions on how to address or fix these alerts. So to fully understand the challenges with SCA tools, we designed a user study based on these four main research questions. We first asked how the users interact with these tools, then what are the challenges when they're deploying the tools, what are the challenges when they're acting on these SCA results, and how can the entire SCA process be improved? To answer our four main research questions, we conducted 20 semi-structured interviews with industry professionals. We talked to each of them for about 45 minutes, and the structure of our interview is based on the four main research questions we had. We first asked them about the SCA demographics, general usage, then we move on to how they integrate the tools, and then what happens after they receive outputs from the SCA tool. If we have time, we talk about tool features or measures. Finally, we ask them about their opinions and what improvements they would like to see. So after talking to all the industry professionals, we found multiple challenges and we grouped them into three themes. The first thing we found was that there's a lack of information in the vulnerability alerts, and it requires a lot of additional manual effort. For example, the majority of our participants shared that they would receive a lot of alerts from the SCA tool, then they would have to triage and prioritize them to figure out which ones to focus on first. Some common methods of prioritization mentioned. The first one was using severity metrics, for example, CVSS scores or severity scores from the SCA vendor. Another thing mentioned was evaluating the time and effort needed to fix the vulnerability. And another very important one was using the impact the vulnerability had on the application to determine whether or not they should be prioritized. But to determine the impact of a vulnerability itself is very challenging. Multiple participants shared that they did not have enough context from the vulnerability alerts, and often they would have to put in additional manual effort to find information about the CVE, how they're using the vulnerable library, etc., and then to determine whether or not the vulnerable function is actually reachable from their application and whether or not it would be exploitable. The second theme we found after talking to participants was when and how the SCA tool run in development pipelines matter. If they are not configured correctly, they can end up causing halts or challenges in your development pipeline. Some of the challenges participants shared was unsupported scripts or legacy languages in their application, and they would not be supported by SCA tools. So in order to figure out what is actually in their software components, they would either have to pre-process things themselves or find a workaround with the SCA supplier. Another thing mentioned by participants was if their application had different ecosystems, they observed that SCA tools would perform differently for different ecosystems or languages. And the reason is that is because package managers for different ecosystems have different ways of resolving libraries and dependencies, and an SCA tool may not be able to take into consideration all of that. Another thing mentioned by participants was sometimes because they have multiple languages and ecosystems in the entire software stack, and they also want to figure out what components are in all of them. They sometimes would have to use multiple SCA tools because some perform better for certain ecosystems and worse for others. But trying to piece together all the different SCA tools itself is a very big challenge because SCA tools are not designed to work together, and they have to write a lot of wrappers around each SCA tool, and that involves a lot of maintenance effort. The second part of how an SCA tool can create challenges in your development pipeline relates to how it's being used in your CI/CD pipelines. So the majority of participants share that they use SCA tools in the CI/CD pipeline, which means they can act as security gates and reject code commits or pull requests, so they can fail builds on their own. And sometimes this would introduce a temporary halt or stop in the development pipeline. But if this happens too often, then it becomes an annoyance for the developing team. And the participants shared that previously they had the SCA tool integrated in the CI pipeline, but it was introducing so many stops and halts in the process. They switched to just running it manually once every week. And to prevent this, I think it's important to consider that SCA tools can block a lot of alerts, can block your code commits on a lot of alerts. And it's important to only focus on the critical alerts that really matter to your application and only block development processes on those. The third thing we found after talking to developers kind of combines the challenges with the first two themes. Challenge with lack of context in the alerts and the lack of context when you're integrating the tool can generate overhead in your entire process. And this overhead can be amplified when you're trying to scale SCA to multiple projects and multiple teams. The overhead can be present when you're trying to fix or address a vulnerability. And the easiest way to do that is update your vulnerable library to a non-vulnerable version. But sometimes you will run into issues like version compatibility issues if you update to another major version that could cause a breaking change in your application. And when that happens, developers often have to put in manual effort to patch it themselves or work around the vulnerability. One participant shared that they ran into a very particular case where they had to use a vulnerable library, but it was causing compatibility issues. So they forked the entire library and took out the vulnerable code and then used that as their upstream library. But that was a lot of manual effort required to fix the vulnerability. Overhead can also be present even if you're not fixing vulnerabilities, because sometimes it requires a lot of back and forth between different teams. For example, the security team might say, oh, we found this vulnerability, but then they pass it on to the engineering team, and the engineering team might think that this does not present actual risk to the application, and a lot of back and forth happens to decide how to resolve this. Other cases where you do not fix the vulnerability may be related to business decisions. For example, the participants shared that In some cases, to fix a vulnerability requires a lot of time and effort, but the company really has to ship this product or they won't have any business. And in this case, business risk outweighs the security risk. So they might temporarily accept the vulnerability risk. Other participants also shared that sometimes there is simply no alternative non-vulnerable code available on the market. They shared that sometimes they work with component suppliers that are the only supplier in the market, so there is no other alternative they can go to. In the cases where there is a security risk, but they decide to temporarily accept or not fix it, the participants share that they often decide to isolate the vulnerable component, for example, by removing network access. By removing network access, you basically eliminate the possibility of untrusted data flowing into your application and exploiting the vulnerability. Relating to how the overhead in the SCA process can be amplified when you're scaling SCA to multiple projects or teams, we observed that in bigger organizations, because they run SCA on more projects, they have more components, and they receive more vulnerability alerts. All the engineers may not have enough time to go through all of these alerts. So oftentimes, they will develop their own custom tooling around the SCA results. And this would automate some processes and take off the manual burden from developers. One of the participants shared that the custom tooling they built can learn from previous evaluations and bring that forward to newer findings. But this requires like a dedicated separate team that would have to develop and maintain this custom tooling. And for smaller organizations, they oftentimes are not able to do that. So an engineer may have to cover the entire software development lifecycle, also cover the entire SCA process, including fixing the vulnerabilities. So to summarize, we found that there's a lack of context along the entire SCA process, including when you're integrating SCA tools, when you're trying to interpret the vulnerability alerts, and also when you're trying to fix or adjust the alerts. And as you scale SCA tools to more projects and more teams, the overhead caused by the lack of context can be amplified. And to fix that, we propose that SCA tools should have more context, specifically these 4 types. Reachability context can be very useful to reduce false positives, where a vulnerable library is being used, but you're not actually reaching the vulnerable function. Infrastructure context can be very helpful when you're trying to understand how the vulnerable library you're using interacts with different parts of your application or the tech stack your application sits on. And related to that, network configurations can also be very useful, as some participants share that sometimes they have software sitting behind firewalls or software that's completely removed from the network. And in those cases, untrusted data would be less likely to flow into these applications. And then combining all of that and determining whether or not the vulnerability is actually exploitable based on reachability, also based on network configurations, and how your infrastructure is set up can be very useful in determining whether or not you need to address this vulnerability. As for SCA users, there are a few things to keep in mind to reduce the overhead in the process. It's important to understand that each tool has its strengths and weaknesses. And that can be useful when you're trying to understand and evaluate the tool output. Also, finding a tool that works with your pipeline, whether you're integrating it automatically, integrating SCA tools into your CI/CD pipeline, or you're running it periodically. Finding a tool that works with your pipeline would reduce a lot of headaches and overhead. And also keep in mind that fixing vulnerabilities or SCA alerts requires collaboration between multiple teams. So it's important to keep those communication channels alive so you could easily communicate vulnerability results to different teams and fix the vulnerabilities more efficiently. And that concludes the presentation for our study. This is a high-level overview of our findings. If you're interested, there are a lot of interesting quotes we put in the paper, and I also have a short blog post summarizing some of our findings and interesting quotes. Thank you.